Dear friends and colleagues, welcome back to the Mangano Digital Academy. In this lecture we will talk about the intraoral scanner, very important devices for the data acquisition, for the 3D data acquisition in digital dentistry. And we will start from the most important thing, the trueness of the intraoral scanner. So the question we will try to answer today is, what is the trueness of an intraoral scan? Because we should refer obviously to the intraoral scan itself and not to the scanner. There are a lot of variables that need to be considered, and let's talk a little bit about the intraoral scanner. The intraoral scanner, they emit a light source. Usually it's a structural light grid or sometimes a laser on the teeth surface, and then they capture its modification through powerful cameras. And the collected data are then used to calculate the spatial coordinate at each point of teeth surface, and a powerful 3D reconstruction software generates point clouds that are then triangulated into meshes. So what we obtain is a mesh. As we can see here, we have a point cloud, and then it's triangulated, interpolated into a polygonal mesh, and then we have our standard tessellation language file, the STL. So basically a structural light grid with known geometric properties is projected onto the object to be scanned, usually the model of our patient model, and then this grid undergoes a deformation. This deformation is captured by the cameras. The cameras send all information to the software, and the software re-elaborate, thanks to very powerful algorithm, a point cloud, and then this point cloud is used to construct a polygonal mesh through a process that is called interpolation. So a mesh is a set of triangles, usually we talk about triangles, that form the external surface of the scanned object. So we are talking about a 3D reconstruction of the surface of the object, obviously, and not the whole object. We are talking about surface reconstruction. But the question is this surface reconstruction really reliable for us? Can we really trust it? I mean, is it accurate enough, or there are any deviation between the reconstructed and the actual surface of the object? This is the question, because it is the most important question. What is the error? Is it possible to run into errors during the scan? And basically, the answer is yes, of course. We have several kind of possible error, and we have a systematic error, and the trueness is the estimate of the systematic error. And then we have also a random error, and precision is the estimate of the random error, and together trueness and precision, they give the final accuracy of the device, so the total error of the device. And we need to consider that yes, accuracy is a sum of trueness plus precision. So the trueness is the estimate of the systematic error, and we need, of course, a reference value or a true value if we want to evaluate trueness, because we need the true value, or maybe a reference value that must be very close to the true value, because otherwise it's not possible to determine the trueness of a model, for example, a dentate model. Obviously, a reference value has uncertainty, but usually a very small one, so it can be considered a reference for us. Because it's not possible to, unfortunately, it's not applicable to use machines with certified accuracy, like, for example, articulated arms or industrial optical scanner inside the patient's mouth. Having a certified reference file is not possible for us in vivo. So measuring the trueness of the optical impression with intraoral scanner in vivo is quite tricky, it's difficult because of the lack of this reference. Some colleagues try to introduce some devices inside the mouth with known geometric properties in order to have some reference, but it's not so easy to calculate them. Precision is something different. We will talk about precision in details later in one of the next lectures. For determining precision in vivo, it's not necessary to have a reference value, so we simply can take, for example, 10 scans of the same patient and then superimpose them, and we can see if there are variations, if there is a random error, and then precision is the estimate of this error. But let's go back to the trueness, because trueness is much more important. It's probably the most important thing, and it's the key factor in determining the accuracy. So trueness is the ability of a measurement to match the actual value of the quantity being measured. So as we can see from this graph, it's really pretty clear that trueness and precision, they cooperate in determining the final accuracy, but of course in one we can have a model that we can have an intraoral scanner, for example, that is highly true but is possess a low precision, or we can have a situation like with a very low trueness and high precision. Obviously what we want to achieve is high accuracy, because with high accuracy we can really trust in our model and we can use our model for clinical purposes very well. So the point is to have high trueness and high precision at the same time. It's key in order to work well with intraoral scanner. Accuracy is defined also as the closeness of agreement between a measured quantity value and a true quantity value of a measurand. And trueness in particular is defined as the closeness of agreement between the arithmetic mean or large number of test results and the true or accepted reference value. So we are talking about something that is really important for the evaluation of the quality of a mesh or 3D surface reconstruction, because if the 3D surface reconstruction is true, then it is a reconstruction that is reliable clinically. But as I have anticipated you before, to evaluate trueness, we need a reference. And in case of dental models, this is usually an acquisition made with a very accurate machine, like an industrial optical scanner with a certified accuracy of less than 5 micrometers, or maybe a coordinate measuring machine. So something that is really reliable in capturing data of an object, and so we can compare our intraoral scans with those data in order to evaluate if our scans are reliable or not, if they are true or not. Precision is instead the closeness of agreement between measured quantities values obtained by replicate measurements on the same objects, so under specified condition. So it's more a closeness of agreement and deviation between test results. So we don't need a reference in vivo to evaluate the precision, because it is sufficient to compare different measurements, different scans made in the same object under the same conditions at different times in order to evaluate the deviations between them, among them. Anyway, we need to be very clear when we talk about intraoral scanner and we talk about precision, we talk about accuracy, we talk about trueness. We are not talking about the final clinical precision of our restoration, because in prosthodontics, this term clinical precision refers to the whole workflow. I mean, the marginal gap of a restoration. And so this marginal gap should be ideally between 25-30 micrometers. Some authors also goes until 100 micrometers. But the point is that if we talk about the fit and the marginal precision of a crown, then we are talking about the whole phases of the digital workflow. So these results is determined by several phases. The scan phases, of course, but also the plan phases, how we manufacture our crown, for example, how we cement our crown. So we need to consider that our definition of trueness and precision related to the scans, related to the scanner, has nothing to do with the final clinical precision, because the final clinical precision depends by more factors at a different level of the workflow. So it's very important to consider this. And when we talk about trueness, we'd better refer to the mesh instead of the intraoral scanner itself, because obviously there can be also deviations, some kind of standard deviation among the different meshes of the different object captured with the same intraoral scanner. So it's very important to say that the final trueness of an optical impression of a mesh of a 3D surface reconstruction depends not only on the intrinsic accuracy of the intraoral scanner. Of course, it depends by the scanner, but not only. There are also other factors, for example, the operator, the experience of the operator, the strategy, the scanning strategy are very important. Also, patient-related factors are quite important. For example, the number of remaining teeth, for example. We all know that a full, completely edentulous patient is much more difficult to scan than a dentate patient. Then the environment, the light condition, and there are also some additional components. For example, in implant prosthodontics, we talk about the scan body. So everything together contribute to the final trueness. So it's much better to define trueness as an element of the mesh itself and not the element of the scanner, even if the scanners, different scanners have different trueness, of course. So when we talk about implant impression, for example, as I told you, yes, there's the scanner that is important because there's an intrinsic accuracy of the intraoral scanner, but also there are other factors, the operator, the strategy, the experience, the patient, number, for example, inclination, depth of the implants, the environmental condition, light, temperature, the scan body, that is a very important factor in determining the final accuracy of implant impressions, particularly in the case of full arch implant impression. And then the congruence, that is a topic that we will treat and face in detail in one of the next lectures. So there are several factors, not only the intraoral scanner. Anyway, I think that the intraoral scanner is the #1 factor we should consider. So what is the trueness of full arch implant impression? Because it's very often the colleagues pose me this question because it's considered very important, and of course it's the most difficult application for the use of intraoral scanner, but it's very important and an hot topic, I would say, also in literature. And I have conducted along with Professor Oleg Atmakin and the team of researchers cooperating with me, this very interesting research published last year in the BMC Oral Health, and it's basically a comparison of 12 different intraoral scanners in the full arch implant impression. It's an in vitro study because, as I told you, it's very difficult, it's quite tricky to perform an in vivo study of the trueness of intraoral scanner and model generated by the intraoral scanner if we don't have a reference, and of course in vivo we don't have any reference file. So basically we compared these 12 intraoral scanner, and we captured 10 models with each one of these intraoral scanner. We compared this model with a reference model captured with a very powerful desktop scanner. We superimposed the model using different techniques, a mesh-to-mesh techniques, a NURBS to NURBS technique, in order to understand something about the overall trueness of the different model captured with the different scanner. We wanted to understand if there was some statistically significant difference among them, but at the same time we decided to calculate the linear and cross distances between the centroid of the scan bodies in order to have really reliable data, because we all know that with the progression of the scan the error grows, and therefore it's very important to consider this factor. The progression of the error is not linear, and so it's important also to evaluate the linear distances between the different scan bodies. And basically these were the machines that we have evaluated: iTero Elements 5D, PrimeScan from Dentsply Sirona, and Omnicam from Dentsply Sirona, CS3700 and CS3600 from Carestream Dental, Trios 3 from the 3Shape, the Medit scanner, then 2 scanner from the Planmeca, Emerald S and Emerald, Virtuo Vivo and DWEO from the Dental Wings, and then the RunEyes, Chinese scanner. And all these kind of use different technology for the acquisition of the data, of 3D data, and also for the making the mesh, so the different algorithm for the interpolation. So it's very interesting to evaluate the differences between these different scanners. This was the reference model prepared for me from in the laboratory of master dental technician Uli Oshild. It was a situation that is quite tricky clinically, so a full arch maxilla with 6 implants. The implants were quite parallel each other. These scan bodies were from the Megagen company. And this model was scanned a few times with a very powerful and certified reference desktop scanner. It's a desktop scanner with a very high accuracy, the DOF. And then we captured different models. We chose one model, the best among all these models, and we considered it as a reference. And then I captured in person 10 scans with each one of these different intraoral scanners in order to generate around 120 models from the different intraoral scans, and then we superimposed, we compared basically all these models with the reference model by means of a reverse engineering software. So the comparison was made through 2 different systems, mesh to mesh, a direct superimposition between the 2 meshes, and then a NURBS to NURBS technique. The NURBS to NURBS technique is quite different because, and I think it's more interesting because before to make the superimposition, we replace the library for each scan body inside every single mesh, captured mesh. It's a very long work, very difficult, but very important in order to get a very good information about the quality and the trueness of the intraoral scanner. So the scanning strategy was almost the same for all the scanners, in the same where the condition, the environmental condition. I used this zigzag technique that is quite, established in the world of intraoral scanners, and we performed then the superimposition, and we evaluate the overall trueness with a mesh-to-mesh method, and then the overall trueness with a NURBS-to-NURBS method. With the NURBS-to-NURBS methods, as I told you, the library file of the scan body provided by the implant manufacturer was superimposed to each of the 6 scan bodies present in each iOS scan mesh. And then for each iOS scan, a new file was generated and obtained with only the 6 implant scan bodies library file in a position in the space free. This position was derived from the original mesh. And the same procedures were repeated for the reference mesh, and then we superimposed it. So basically it's a different way to evaluate the overall trueness of the models. And this is how it works with the mesh-to-mesh technique. In this short video, we can see the reference file and we can see the intraoral scan. We can use the reverse engineering software. First, we pick a few points in corresponding part. We have a rough alignment, and then we launch the algorithm for the best fit is an iterative closest point algorithm, very powerful. Then a point-to-plane method is used to stabilize the superimposition, and then we can generate also a colorimetric map with the threshold that we want. In this case, we see that the green is very good results because it's less than 30 micron deviation, and for the other color we have deviation, of course. This is the mesh to mesh, so we have repeated this work 120 times, and this is the superimposition NURBS to NURBS. As we can see, we have the position of the libraries. From the one side on the left, derived by the reference acquisition with the desktop scanner, and on the other side, the right, derived by the intraoral scan, and then we superimpose it. So basically here we have a superimposition of library files, but in the position given by the mesh. And once again, we have this situation with green that is good, and blue and light blue, and then pale blue, they are not good enough because there are deviations. And here in this table we can see the overall trueness, and there were a lot of, there was evidence of statistically significant differences from this table, as we can see here, because some machine like the CS3700 and iTero Elements 5D, they performed particularly well in the evaluations. In this evaluation, and as we can see, we have a group of scanners that are, very true, very accurate, and these scanners are the iTero Elements 5D, the Prime Scan, Trios 3, the two scanners of Carestream Dental, CS3600 and CS3700, that they are very, very accurate. And Of course, there were some deviations among the mesh-to-mesh and the nerves-to-nerves evaluation, but more or less I could say that these scanners, the 6 scanners that I cited, they worked very well in terms of trueness, overall trueness, and as we can see here, very little deviations comprised among 25-30 micron for iTero Elements 5D, the Carestream scanner and the Medit scanner. For the mesh-to-mesh evaluation, actually the best results were obtained by CS3700 in this kind of evaluation, the mesh-to-mesh for the overall trueness. For the nerves-to-nerves evaluation, the best results were obtained by iTero Elements 5D. Very interesting that is less than 17.5 micron of deviation on the full arch. So we are talking about very little error compared to what we could achieve even 5 years ago. I mean, the trueness is clearly much better. In this case, we used our reverse engineering software, and what we are talking about is the absolute deviation. So we are not talking assigned mean, we are talking about the absolute deviation. Anyway, there are also other methods to evaluate the overall trueness that can be also more reliable, like the root mean square or the 90 minus 10 and divided per 2 method that are 2 more recently introduced methods that I didn't use in this study. Anyway, overall trueness revealed a statistically significant difference among the different scanners with the mesh-to-mesh method, and these were in this figure. You can see the best results achieved with each one of the scanner for the mesh-to-mesh method. As we can see, we have very good results. Anyway, for the best scanner, less than 30 micron error. And here the table summarizing the results with the nerves-to-nerves method. Once again, statistically significant differences between the different machines. And once again, a figure that summarizes the results, the best results achievable with the different scanner. The best results achieved in the whole study was a 9 micrometer deviation in the full arch with the CS3600. And it's impressive because 9 micrometer of deviation, it's very little. It's something that is almost perfect. We rise perfection here. But also with iTero, the results were excellent. With PrimeScan, with CS3700, there are very little deviation. I mean, everything is very satisfactory. And what we can achieve now was not possible to achieve even a couple of years ago. And I conclude with the linear measurement because it's very important, as you can see, to consider the progression of the scan. And we evaluated linear and also cross distances between the center of the centroids. And of course, the cross distances we expect, with the cross distances we expect huge errors because of course the distances are huge, and the error can be of course higher in these cases, and it was so actually. So we collected all measurement with the reference model, and then we compared this measurement, these values, with the values obtained with the distances of every single scan captured with the different intraoral scanner. We are talking about 120 meshes in these cases. Of course, we had to replace the library files inside the mesh in order to make this evaluation correctly, because this evaluation can be made automatically by the software only on a library file in which the centroid of the scan body is automatically found by the software. And once again, we had, of course, statistically significant differences between the different scanners, and obviously we had a higher variation, higher dispersion of the error for the cross distances. It was expected, but anyway, more or less, we had this group of leading scanners capable to guarantee best results, like the Carestream scanner and also the PrimeScan, the Trios, the Medit itself, and iTero Elements 5D. So these were the scanners capable to grant the best results in the different applications. And of course, there were statistically significant differences in terms of trueness among the linear and also among the cross distances between the different intraoral scanners. So if we consider the first variable of the graph, the intraoral scanner, then we need to say we need to admit that there are statistically significant differences among the different scanners. So the scanner is a factor, the scanner is a very important factor in our workflow, and we need to choose the proper scanner, particularly for some kind of difficult application like the full arch scan. As we can see here, particularly the results in the cross distances are, I mean, difficult to achieve, and with the best scanner we can limit our error and we can achieve a higher accuracy. So the conclusions from this study is that there were statistically significant differences in trueness between different intraoral scanners. So the factor scanner exists because some intraoral scanner like CS3700, iTero Elements 5, PrimeScan, made it, Trios, and CS3600 granted more suitable results for the full arch impression. So they should be used for this particular application. This represents a specific indication for this clinical application. Obviously, different evaluation methods determine different results, and there are also limits, intrinsic limits in this study. It's an in vitro study, but of course we cannot perform any in vivo study actually with this for the trueness, because it's quite difficult, it's tricky to introduce a reference object inside the mouth. Maybe the scanning strategy used here, the strategy may have favored some scanner over the others. The use of a desktop scanner can be, I mean, a critical point, but in this case it's a scanner with a certified accuracy of less than 5 microns. So we are talking about a desktop scanner that is very powerful and very similar in terms of result with an industrial optical one. And the other limitation of this study is that we didn't start from the same scan body in all the scans. So we couldn't evaluate perfectly the scan progression, and they're related to the scan progression, but it's a limitation of this study, and we will try to overcome this limitation with the next studies. So thank you very much for your kind attention. I'll be very happy to receive your comments, your criticism, your question. You can write me here. Please keep following me in the Mangano Digital Academy social channels, and thank you very much for your kind attention.